Right, combinations homework question 3. Here we've got a set A with the number of elements is equal to 6. So we want to find the number of subsets that have 2 elements. Well, we've got a total of 6 elements and we want to pick 2 elements. So we've got the combination 6 choose 2. So we can remember our formula, which you can see in red on the right there. So we take the 6 and take the factorial. And so we have 6 factorial in the numerator, divide by 2 factorial, and the difference between 6 and 2 is 4 factorial. So now we can do some cancellation. We know that 4 factorial is in 6 factorial, but then we have left over is 6 times 5, and 2 factorial is 2 times 1. If you 30 divided by 2, that gives us 15. Now, because we're using this question has a lot of parts to do with n equals number of elements equals 6, it may be useful to draw out Pascal's triangle, which we'll do in a moment. But first, let's have a look at the number of subsets that have 6 elements. Well, if you've got 6 elements in the set, there is only one way we can arrange it, otherwise it will not be unique. So we know that the answer to this has to be 1. But let's think about this in terms of combinations as well. The way we could work this out would be to say there's 6 elements and we need to choose 6. And we know that this is the last row, or the right-hand row of Pascal's triangle. We'll draw that to the right. So I've just drawn up to the 6th row here, and we can see that the first element is the number of ways we could choose no elements, that's the empty set, and this last here, which you can just see on the edge of the screen there, there's only one way you can choose 6 from 6 elements. Alright, so on to part C. We can have the number of subsets that have less than 5 elements. So everything less than 5, well, we've got 0, we could have 1, 2, 3, 4, and let's write them in. But we'll not include 5 elements because just less than, not including 5. So we can look at these most easily from the triangle, Pascal's triangle. We can see there's 1 plus 6 plus, just reading across the row there, plus 20 plus 15. And if we add all of that up correctly, we should get 57. Okay, so part D, having more than one element. Well, we could do the same thing as we did in part C and just list out every aspect that's true for. So for, there's more than one there for 2, for 3, for 4, for 5, for 6, etc. But instead, it's going to be much more easy if we use the complement, if we say the total and subtract 1 or less. So in this case, the total number of subsets we know is 2 to the power of 6, which is going to be 64. 2 to the power of 6 minus 1 or less, so we've got 7. And that gives us 57, which you'll notice is the same answer as we get in part C. And I think if you think about it for a little while, you'll be able to see why that's the case because of the symmetry of Pascal's triangle. Right, so part E, have at most 4 elements. Well, that means you could have 4, but you could also have less than that, at most 4. So we could have 1, let's say less than 4, less than 4, here we go, less than 4 plus 4. So in that case we could say 1 plus 6 plus 15 plus 20, so we got 0, 1, 2, 3, and this is 6, choose 4 here, so plus the 15, which we will get, surprise, surprise, the same answer, 57. It keeps coming up because of the symmetry. In fact, you'll notice that calculation was actually unnecessary if you look carefully at question C. Less than 5 and at most 4 are actually the same thing, which is why we have the same calculation, the same answer. So having at least 3 elements now in the last part means that we can have 3 elements, but also that's the least number. So we could also have 4 or 5 or 6. And if we look from Pascal's triangle, we can see here that 6C3 here is the 20, so we say 20 plus 15 plus 6 plus 1, and that will give us 42. Of course, we could also use the complement. We could take the total, and we could say subtract less than 3. Less than 3, and we'd get the same answer here, 42. So in summary, we can calculate combinations with the formula here, or we could use Pascal's triangle. And we could, when we have less than or most, at most, these sort of things, we could use lists and add them together, or we could use the strategy of using the complement.